Particle's moving in a straight line at time t seconds, where t is greater or equal to 0. It has velocity v and acceleration a, where a is given by this. So this is not constant acceleration. We can see acceleration is dependent on time. It's in fact going to be increasing as time increases. We're also given that v is 2 when t is 1. So I'm going to write down a differential equation for this technically. It's dv by dt, that's my acceleration, is going to equal 4t minus 9. And therefore, to work out v, we integrate. We've got the derivative, we want to work back to v, we're going to need to integrate. I'm not going to put the integral sign around it, I'm just going to go straight for it. So raise the power by 1 to 2, divide by 2, it's going to give us 2t squared minus 9t, and then don't forget there's going to be a plus c, which we can now find because we're given this condition when v is 2, when t is 1, v is 2. So 2 is going to equal 2 minus 9 plus c. It must be that c is equal to 9. And therefore v is 2t squared minus 9t plus 9. Particle is instantaneously at rest at two different times. T1 is less than T2. Find these values. So this is going to be when v is 0. So 2t squared minus 9t plus 9 equals 0. Now we're in the mechanics paper. It's absolutely fine to just use your calculator to solve this quadratic. This one actually does factorize, but often they don't, and they won't in a kind of mechanics setting. But we get 3 and 1.5. It is actually expected in the mark scheme that you use your calculator function as well, just for speed. Although it wouldn't have taken too long to factorize. Okay, finally, determine the total distance traveled by p between times t equals 0 and t equals t2, which we now know is 3. Now, be warned, do not just integrate between 0 and 3. Always draw a little sketch of a velocity time graph to see what's going on. Now, we have that it's when t is 0, the velocity is going to be 9. So I'm going to add that on. That's not really going to come into it. It's a positive quadratic, like a happy quadratic, but it goes through the axis at 1.5 and 3. It's going to look something like this. What that actually means is between 1.5 and 3, it's traveling at a negative velocity. So it's going to be coming back towards the start. But because we're interested in the distance, actually we want to find not, we don't want to, if we just do 0 to 3, we just find the overall displacement. We need to split it up. So our first integral is going to be from 0 to 1.5. This will give us this positive displacement. And we're finding s, so we're going to be integrating v. I should have said that before. Because remember, the s by dt is v, so to work back, we integrate v. Now, we can actually just put this in our calculator. We don't need to integrate the whole thing, but make sure you can. So we just substitute t for, or x for t, 2x squared minus 9x plus 9. We should really put a bracket around this, but the calculator knows that's what we mean. 0, 1.5, get 5.625. Okay, now to find this. It's the same integral. and we get minus 1.125. So the distance traveled is going to be 5.625 plus 1.125, or you can minus the negative. That's what I'm going to do here, which gives us 6.75. That's our answer. Okay, these quite often come up. So yeah, I just want to say again, like get a velocity time graph drawn. Think about, where you've got positive displacement, negative displacement. If we're interested in the distance, we need to split it up into these two different parts, or maybe more than two different parts if it's even more complicated. Well done.